In this video, we're going to go over financial functions, data tables, goal seek, and scenario manager. So let's start with financial functions. We have several that we're going to look at. The first one that we're going to look at is the PMT function. PMT function will calculate the payment that you need either for a present value problem, like buying a house or a car, or a future value problem, like saving for retirement. So the first thing that I'm going to do is just going to make our PMT function a little bit easier. I did a car payment calculator. I'm first going to click in cell B8 and calculate the amount financed, which is going to be the cost of the car minus the down payment. I could put that into the PMT function, but it's just a little bit easier that way. So now to calculate the monthly payment, I'm going to use the PMT function. So I'm going to go to Formulas, Financial, and then scroll down until I find PMT. So the arguments in PMT are rate, which is actually the financial function I, which is the annual rate divided by the number of payments in 1 year, and per is the finance function N, the total number of payment periods. Then PV becomes the amount that you're going to finance today and pay back later, for example, a house or a car loan. If you wanted to save for retirement, instead of putting the amount in PV, you put it in FV because that would be the amount that you wanted to attain after you retire. So now I'm going to click in rate. I'm going to click on the 6.7%, cell B5, and then /12. In the N per, everybody knows that if you have a 5-year car loan, you're going to make 60 payments. So I'm going to click on the number 5 and then multiply that by 12. So now in the PV, I'm going to type a negative sign. If I don't type a negative sign in the PV, the answer will come out negative, which makes sense because you're making the payment. And I'm going to click on the amount financed. So had I not calculated the amount financed, I would have had to do parentheses here and take the cost of the car minus the down payment. So we can now see that the PMT function gives us $412.86 a month. And now it's set for a what-if analysis. We're going to go into a little bit of what-if analysis in a little bit. But now with the what-if analysis, we can change any number. So for example, I can change the years from 5 to 6. Or I can change the cost of the car to $22,000. I can change the down payment. And the monthly payment will recalculate automatically. Now let's move on to our FV function. All of these functions are very, very similar. FV is used when you want to make payments and attain an amount in the future. So in this case, I'm going to say $500 a month. That this time I made it a little different, that I added the frequency. So 12 means you're doing it monthly. So let's say you want to save $500 monthly for 25 years at an annual rate of 4.5%. How much money will you retire with? And hint, it's not quite as much as you think. So I'm going to go into Formulas, Financial, and this time I'm going to click on FV. Returns the future value of an investment. So again, the balance you want to attain after the last payment is made. So in this case, I'm going to click on the 4.5%, and then I'm going to / and click on the 12. Instead of just typing 12, this way we could change it to quarterly payments or semi-annual payments, whatever frequency we want. In N per, I'm going to click on the number of years, 25, cell E6, and then multiply it by the frequency, 12. So in 25 years, you would make 300 total payments. And in the PMT box, since we're making this into a fund, we're actually spending money when we save, I'm going to type a negative and click on the 500. And notice you're going to have 2,700,000, nope, $276,499. So I told you it's not really very much money, but before I click OK, I want you to notice that there are no numbers, only cell references within my function, which means that I can change any one of these numbers, and the function is based on the numbers in the cell, not numbers. So for example, I'm not limited to 12 months during the year. I'm not limited to an annual rate of 4.5%. So I'm going to click OK, and yes, I was having trouble reading, but it is about $276,500, which in 25 years will be worth about $500. So notice that you really have to save a lot in order to retire with a lot of money. Now let's look at the PV function. With a PV function, we know how much money we want to pay per month for a house or a car, but we don't know what that represents. So most people go shopping for a car and they say, well, I can afford $300 a month, I can afford $350 a month, but they don't really know how expensive a car they're shopping for. So for this answer, we can use the PV function. The difference between the PV function and the FV function is that when I retire, I get my money after the last payment is made. Now, when you're talking about a PV function, once again, that's like buying a house or a car. And when you buy a house or a car, it's not like you make 5 years of payments or 30 years of payments and then you get the house or the car. You get the house or the car before you ever make the first payment. So that's basically the difference between an FV problem and a PV problem. I know that they can be confusing. Now you're going to see that basically these financial functions are very similar. They're going to ask for IN, some kind of payment, present or future value. So as long as you know how to model it, you can get the correct inputs. So formulas, financial, and this time I'm going to use PV. So in this case, my rate is going to be 8.6%. So I'm going to click on the 8.6%, and then I'm going to divide by the 12 for monthly. So H5 divided by H4. N per is the number of years multiplied by 12. So I'm going to take the 6 years, H6, and multiply that by the frequency, which is H4. And then in the PMT, I'm going to type a negative and then click on the $350, and you are shopping for a $19,600 car. If you can afford $350 a month in payments, you want to go 6 years, and the dealer quotes you an annual rate of 8.6%. Now let's look at 2 more functions before we move on to data tables, GoalSeek, and Scenario Manager. The next function we're going to look at is N per. N per will actually solve for the number of payments that you need to make to either pay off a loan or achieve a certain value in the future. Paying off a loan would be a PV problem. Achieving a balance in the future would be an FV problem. So let's say you have $15,000 on your credit card with an annual rate of 15.8%. You're willing to make monthly payments of $500, and you want to know how many payments it's going to take you to repay that loan. So I'm going to click in cell K8. I'm going to click on Formulas, Financial, and N per. Okay, so with N per, I'm going to take the annual rate, and I'm going to divide by the frequency. So K6 divided by K5. My payment is going to be negative $500. Now, of the PMT and the PV or FV, one of them has to be negative and one of them has to be positive. So I can't borrow money and then receive money. I can't invest and then keep putting more in. That's like an infinite interest rate. So basically, you're borrowing money today, you're getting it today and paying it back in the future, or you're putting it into a fund today and getting it in the future. Now, if I wanted to save $500 a month and wanted to know how long it would take me to get to $15,000, I would put it in the FV. But in this case, I already have right now $15,000 of debt, and I want to know how long it's going to take me to pay it back. So in the PV, I'm going to put in 15,000, and I'm going to click OK, and it would take me 38 months to pay that back, so a little bit less than 2 years. 38.4, so in the 39th month it will be paid back. Now here's another nice function that's very helpful if somebody will tell you how much the payment is, but they won't tell you how much you're paying for interest. So let's say you're going to rent a center and you see a $3,000 couch. They're offering it to you for $45 a week for 3 years, and then it's yours. Well, the rate function, because this is a weekly payment, will tell you how much interest you're paying per week. So to calculate the annual rate, you would take the weekly rate and multiply it by 52. If this was a monthly payment, you take the monthly rate, and multiply it by 12. But because this is a weekly payment, the annual rate would be the weekly rate multiplied by 52. So first I'm going to use the rate function, formulas, financial, and rate. Okay, so my N per is 3 years multiplied by 52 because this is weekly. My PMT is negative 45. And again, if I was saving up $45 a month for the 3,000 future value, that would be in the 3,000 would be the FV, but I'm getting the couch today and then making the weekly payment, so the 3,000 goes in the PV, and because I'm getting the couch, it goes in as a positive number. So notice I get a rate of 1%. If I increase the decimal, you'll see it's more than 1%. So 1.3%, and that doesn't look that bad, but as I've told you before, you cannot look at a rate given in non-standard terms. All interest rates are quoted in annual percentage rate, not per the period. So to truly understand a periodic interest rate, you have to multiply it by the number of periods in 1 year. So I'm going to take 1.3% and multiply it by 52 weeks in 1 year, and you are paying 67.6% interest on that couch, not over the 3 years, but each one of the 3 years that you are paying back that loan. And to prove that, we can put that in percentage style and increase the decimal, 67.6% on that loan. So hopefully we've learned a little bit about financial functions. Now let's move over to data tables. So what data tables allow us to do is to vary either 1 or 2 inputs into a formula and show the results. If you wanted to create a table that would do this, it would involve lots of relative and absolute cell references, or cutting and pasting, or this way the data table just does it. So for extra practice, let's first calculate the monthly payment on the mortgage calculator. Then let's also calculate the total interest. So to calculate the monthly payment, I'm going to click in cell B8. I'm going to go to my formulas, financial, and PMT. So my rate is 6.7% /12 because it's a monthly payment. If you have a 30-year mortgage, NPER is going to be 30 multiplied by 12, so it's 360 payments. Now for the PV, I'm going to type a negative sign, open up the parentheses, and take the cost of the house, subtract the down payment, close up the parentheses, so notice that is the cost of the house minus the down payment. And notice I get a monthly payment of $1,580.93. So before I click OK, I just want you to notice that other than the number of months in a year, 12, there are no numbers. So I didn't type in the 6.7%. I didn't type in the cost of the house. I didn't type in the down payment. This is super important for the data table, because if I change any one of the inputs, it has to change the formula. If it doesn't, the data table won't work. So I'm going to click OK. Now, let me show you how to calculate the total interest paid. The total interest paid is the difference between the total of the monthly payments. So we're making $1,580 a month, 12 times a year over 30 years, so 1,580.93 multiplied by 360 is what you're paying back. And we borrowed the cost of the house minus the down payment. So first, I'm going to calculate what we're paying back. So I'm going to take $1,580.93, the monthly payment. Notice that I'm not typing it in, because if it changes, I want the total interest to change. I'm going to multiply that by 12 payments per year, the only constant. And then I'm going to multiply that by the number of years. So that gives me what I'm paying back. And then I'm going to subtract, open parentheses, the cost of the house minus the down payment. So the total interest, again, is what I'm paying back minus what I borrowed. So we see here that we're going to pay, in fact, more than the cost of the house over the 30 years. You will pay a total of $324,000 in interest. So now, with a one-way data table, we can vary the years. So basically, what the one-way data table would do is change the years to 10. Watch when I hit enter, both of those numbers are going to change. So the computer's going to write it down. Then I'm going to change it to 15. The computer's going to get the answer, it's going to write it down. Then I'm going to change the years to 20. The computer's going to get the answer, and it's going to write it down. So that's basically what the data table does. So with a one-way data table, I want the monthly payment to appear in the second column, and I want the total interest paid to appear in the third column. So to do that, I'm going to do equals, and I'm going to click on the monthly payment formula, the PMT function. Now I could put the PMT function right there, but to me it's easier to create it someplace else and then to make a reference to it. But we could put in the same PMT function here and reference all of the given inputs. Now in this column, I'm going to type an equal sign, and I'm going to click on the total interest calculation. And again, I could have just put the interest calculation formula in here as well, but I've already done it, so I'm just going to make reference to the formula. Now that I've got all that set up, remember the pound sign just means that the column is not wide enough to display the number. Just make the column wider. So now I'm going to select my entire data table, including the formulas, so including that top row, and I'm going to click on my Data tab. In the Forecast group, I'm going to click on What If Analysis and Data Table. So now I always get confused between my rows and my column, but whenever I think of a column, I think of a Grecian column that goes up and down. So for a one-way data table, our only input cell is in the left column. There's nothing in the top row. You'll see when we do our two-way data table, it's different. So I'm going to go into the column input cell, and I'm going to click on the number of years. So again, Excel is going to do exactly what I said. It's going to change the years to 10 and then write down the answer to those two formulas, then change the years to 15 and write down the answer to those two formulas, change the years to 20 and write down the answers to those two formulas. So all I have to do now is click OK, and it has calculated the monthly payment and the total interest paid. I'm just going to clean this up a little bit. I'm going to click Home, and I'm going to click my comma style so we can see that at 10 years our monthly payment is up to $2,800 a month, but we're only going to pay $91,000 in interest. If we take 40 years, our payment is down to $1,469 a month, but we're going to spend a total of $460,000 in interest. One last thing, because this isn't very helpful as to what the columns are, but you cannot delete these formulas, otherwise the data table will not work. So what I'm going to do is I'm going to click on cell B14. I'm going to make sure that I'm on the Home tab, and in the number group, I'm going to click the little number format arrow down in the bottom right-hand corner. Making sure that I'm on the number tab, I'm going to click on Custom. I'm just going to delete whatever is in type. I don't care what's in there, just delete it, does not matter. And I'm going to do double quote, monthly payment, and then close the double quote. What I've just told Excel is I don't care what's in the cell, just slap a post-it note on top of it that says monthly payment. So don't change what's inside the cell, change how it displays. So I'm going to click OK, and notice that it now says monthly payment, even though the content is still equals B8. So now I'm going to do the same thing for column C. I'll change the formula to total interest. So making sure that I'm on the Home tab, number group, custom, just delete whatever is in type, just get rid of it, it doesn't matter, whatever it is, open quote, total interest paid, close the double quote, and click OK. And notice if you were a real estate agent, this would be extremely useful for you to present to a client who is unsure about how many years to go with their mortgage. Now with a two-way data table, unfortunately you can only show the results of one formula. With a one-way I could add columns and columns if I want. With a two-way data table I could show either the monthly payment or the total interest in the body, but I can vary two at the same time. So in this case, I'm going to vary both the years and the down payment. So with the two-way data table in the corner, I either put the formula that I want or make reference to the formula that I want to display in the detail. So in this case, I want to show my monthly payments. So I'm going to do equals and click on the monthly payment. Later we'll change that cell again. Now I'm going to select my two-way data table, go to my Data tab, Forecast group, What If Analysis. Notice we're doing all three in this video: Data Table, Goal Seek, and Scenario Manager. So I'm going to click on Data Table. Now I have both a row and a column input cell. So the row, which goes across, is going to be my down payment. So making sure that I'm in the row input cell in the dialog box, I'm going to click on the amount of the down payment. So it'll substitute 10, 20, 30, 40, and 50,000 for the down payment. And for my column input cell, that would be the number of years. So it'll substitute 10, 15, 20, 25, 30, and 40. So now all I have to do is click OK. Make this look a little bit nicer. So I'll go Home. Use the comma icon so we can see. And once again, click on the cell in the corner, which isn't very helpful. Making sure that I'm on the Home tab, number group, little arrow. Making sure that you're on the number tab, custom, delete what's ever in there, double quote, down payment, / years. Close the double quote and click OK. And we now have our two-way data table. So if we put $10,000 down and go over 10 years, our payment can be as high as $3,150.63 a month. If we go the maximum, $50,000 down payment and 40 years, our payment $1,409.44 a month. Now we're going to go over GoalSeek. So I'm going to move over to the GoalSeek tab. So with GoalSeek, you can actually solve for a particular answer. So right now I'm going to use the monthly payment again. So I'm going to do my formulas, financial, and PMT. So once again, my rate is 6.7% divided by 12. My NPER is 30 times 12. My PV negative, open parentheses, cost of the house minus the down payment, close parentheses. So I get a payment of $1,580 per month. I'm just going to click OK. And now to calculate the total interest, once again I'm going to take the monthly payment, multiply it by 12, and then multiply it by the number of years. That's how much I'm paying back on the loan. And then I'm going to subtract what I'm borrowing, open parentheses, the cost of the house minus the down payment. So now, let's say you wanted to find a house for $1,300 a month, and you were willing to put down $40,000, but you wanted to know what cost would produce a monthly payment of $1,300. So because the answer that we want, $1,300 is the monthly payment, I'm going to click on cell B8, the monthly payment, although it's not 100% necessary, it will just save a step. So now I'm going to go to my Data tab, back to the Forecast group, What If Analysis, and this time GoalSeek. So set cell is the formula. I don't want this to be 1,500, I want it to be 1,300. So my set cell would be the monthly payment. If you didn't click on it, just click on it now. To a value of $1,300. Now the changing cell would be the cost of the house. So I'm going to click OK. And we find that with a $241,000 house, I would have a monthly payment of $1,300. So if I click OK, it keeps it. If I do cancel, it goes back to the original numbers. So I'm going to go back to cancel. Now let's say we're looking at interest of $324,000 and you said, no, I want to go a number of years where I don't pay more than the cost of the house in interest. So I want to make sure I pay less than $285,000 in interest. So this time I won't click on the results cell. Data tab, Forecast group, What If Analysis, and GoalSeek. So this time I want to set the total interest. Now unfortunately in the value you can't click on a cell. We can do that with Scenario Manager but not with GoalSeek. So the value has to be typed in, so $285,000 by changing the number of years. So this will tell us how many years we have to pay the mortgage to keep our interest under the cost of the house, $285,000. I click OK, and if I have a mortgage of 27 years instead of 30 years, my total interest will be $285,000. So again, OK keeps the new number, and cancel goes back to the original number. Now, let's move on to the last one I'm going to demonstrate, which is Scenario Manager. So once again, I'm going to calculate my monthly payment just to give you lots of practice in this. So formulas, financial, PMT, 6.7% divided by 12, 30 multiplied by 12, and then PV, negative, open parentheses, cost of the house minus the down payment, close parentheses, and click OK. Now, let's calculate the total interest. So again, to calculate the total interest, I'm going to take the monthly payment, multiply it by 12, multiply it by the number of years, and then subtract the amount financed, open parentheses, which is the cost of the house minus the down payment, close parentheses, and we are paying a total of $324,000 in interest. So with Scenario Manager, we're going to have changing cells. Our changing cells are going to be all 4 of these, and we're going to have result cells, which will be the monthly payment and the total interest. Now, your book doesn't show this, but Scenario Manager becomes a little bit easier if we name our cells. So I'm going to click right now on cell B3. I'm going to go into the name box, which is right over column A and the first column of numbers. So this over here is the name box. Notice when I hover over it, it says name box. So I'm going to click on the name box, and I will call this cell cost underscore of, you can't use spaces in range names, so cost of underscore house, and hit enter to accept the name. Now I'm going to click on cell B4, click in the name box and change this one to down underscore payment, and just hit enter to accept the name. I'm going to click on cell B5, click in the name box, call this annual underscore rate, and hit enter. And finally, years. I'm going to click in the name box and just call that one years and hit enter. Now I'm going to go into my Scenario Manager. So I'm going to click on the Data tab, Forecast Group. Under What If Analysis, we've already done Goal Seek and Data Table. So now we're going to do Scenario Manager. So notice it says no scenarios are defined. Choose Add to add scenarios. So I'm going to click Add. Now we'll call this scenario name Low Cost House. Now in the changing cells, we're going to want all of our inputs: the cost of the house, the down payment, the annual rate, and the years. So in the changing cells, I'm going to select B3 to B6, that range, and you can put a comment if you want, and I'm going to click OK. So now notice this was the reason when you look in the book, they just have, A1, A2, A3, and A4, but now that we've named the cells, we know what we're doing. So the first one, let's look at a $125,000 house, where we're going to put a $15,000 down payment with an annual rate of 5.5% and a number of years of 20. Now if we click OK, we have one scenario, but if we click Add, we can actually add another scenario. So now I'm going to click Add, and this scenario name I will call Medium Price. I'm going to accept the same changing cells because it includes all of them. Notice I could change the changing cells for my second scenario, and I'm going to click OK. So for this one, we're going to look at a $350,000 house with a $60,000 down payment with an annual rate of 7.2% and the number of years of 25. Now again, if we're all done, we click OK. And if you click OK and you want to add another one, all you have to do is from the Scenario Manager, just click your Add. So I'm going to click Add one more time. And this one we will call Mansion. I'm going to accept the same changing cells, and I'm going to click OK. This time our house is going to cost $800,000. We're going to put $200,000 down. We're going to have an annual rate of 6.2%, and this one will go the full 30 years. Now that I've entered 3 scenarios, I'm going to click OK. And once again, if you want to add more, all you have to do is click Add. So now, the least exciting thing is that now I can click on each one of the scenarios and just click the Show button, and it changes it automatically. And notice, because my monthly payment and interest depend upon it, it will recalculate automatically. I can click on Mansion and click Show, and it will show me how much my monthly payment and the total interest that I'm paying on the house. And I can click on Low Cost House, and I can click Show, and it shows me the monthly payment and the total interest that I'm going to be paying on the house. But the nice thing about Scenario Manager is the summary that it generates. So now I can click Summary, and I'm just going to choose a Scenario Summary. But for my result cells, I want 2. I want the monthly payment and the total interest. So in the result cells, I'm going to click on the range B8 to B9. I'm going to click OK, and Excel is going to create a new sheet with my summary. So there is what my scenario summary looks like. So I have all of my changing cells. So I have my 3 different scenarios, and it shows the results of all of my 3 different scenarios. So again, much easier to prepare than having to do relative and absolute cell references or cutting and pasting or things like that. So there we go for our chapter, Financial Functions, Data Tables, Goal Seek, and Scenario Manager.